Welcome to The Explainer. Today, we're diving deep into a single brilliant protein, a protein that's absolutely essential for every single breath you take. We're talking about hemoglobin.
Okay, so let's kick things off with a huge problem our bodies have to solve literally every second of every day. I mean, you've got trillions of cells, right? And every single one of them is just screaming for oxygen to make energy. So how on earth do you supply all of them all the time?
You might think, well, doesn't oxygen just dissolve in our blood when we breathe? And, that's a good thought, but it's not quite that simple. Turns out, oxygen is actually pretty terrible at traveling solo through our bloodstream. It's like a package that needs a dedicated courier, a super efficient delivery service to grab it in the lungs and then zip it everywhere it needs to go, from your brain right down to the tips of your toes.
All right, so it's time to meet the hero of our story, the molecule that's just perfectly engineered for this exact job. And this, my friends, is where the real magic of our biology kicks in.
And here it is, hemoglobin. This is that complex protein just jam-packed into your red blood cells. It's actually the reason your blood is red. But way more important than that, it's the incredibly sophisticated transport system our bodies absolutely rely on to survive.
Okay, let's take a look under the hood and break down its structure. I want you to picture hemoglobin as a tiny vehicle, kind of like a car with 4 seats. Each of those seats is built around this special part called a heme group. And right at the center of every single heme group, there's an iron atom. That iron atom is the key. It's like a little magnetic claw that snatches on to one molecule of oxygen. So you've got 4 seats, all ready for 4 oxygen passengers.
But here's the thing. Hemoglobin isn't just some simple taxi that picks up and drops off on a fixed route. No way. Its design has this brilliant superpower that makes it ridiculously effective. It actually adapts to what your body needs in real time.
So to really get how amazing hemoglobin is, let's compare it to its cousin, myoglobin. You find myoglobin in your muscles, and honestly, it's an oxygen hoarder. It has this incredibly high affinity for oxygen, which just means it grabs on and holds on for dear life. It only lets go when oxygen levels get really, really low. Hemoglobin, though, it's the total opposite. It's an oxygen sharer. Its whole job is to pick oxygen up, but also, and this is crucial, to let it go.
So, what's the secret to this whole sharing thing? Well, it all comes down to one crucial detail that makes it so much more than just a storage tank. It's a little piece of molecular magic called cooperative binding.
So what is cooperative binding? Well, check this out. When the very first oxygen molecule binds to one of those 4 iron seats, it causes a tiny shift. It changes the entire shape of the hemoglobin molecule, and that change makes it way easier for the second, third, and fourth oxygen molecules to hop on. We're talking a massive increase in its desire for oxygen, about 500 times stronger. The analogy of friends going to a party is perfect. Once the first person says yes, everyone else is suddenly way more eager to join in. And the result of all this teamwork? You get this really cool and very efficient S-shaped delivery curve. Now, why is an S shape so brilliant? Think about it. In your lungs, where there's tons of oxygen, hemoglobin just gobbles it up, loading up super fast until it's completely full. But then, when it gets out to your tissues, your muscles, your brain, where oxygen is scarce, that S-curve flattens out. And that means it becomes a generous giver, readily dropping off its oxygen payload, making sure your cells get exactly what they need, precisely when they need it. It's just perfect.
But, a system this finely tuned can also be hijacked. Take carbon monoxide, for example. It's like a molecular imposter. It latches onto those same iron seats, but it holds on more than 200 times tighter than oxygen does. So it effectively blocks the seats, locks the doors, and shuts down the entire oxygen delivery service. And there are other things, too, that can damage the iron and make it useless. That's why messing with this system can be so incredibly dangerous.
Okay, and that brings us to our final section. Because hemoglobin isn't just this amazing oxygen courier, it's also a fantastic barometer for your overall health. It's actually one of the key things your doctor is looking at in those routine blood tests.
So, what are we looking for? Well, these are the typical healthy ranges for most adults. For men, you're looking at about 130 to 170 grams per liter. For women, it's usually a little bit lower, around 120 to 140. Now, of course, other things like your age or pregnancy can definitely make these numbers shift a bit.
So what happens if this critical oxygen delivery service starts to, well, underperform?
If you're feeling tired all the time, just completely wiped out, it could actually be a big clue that your hemoglobin levels are too low.
This condition has a name you've probably heard of: anemia. When your hemoglobin is low, it means your body's cells are basically being starved of oxygen. And that's what leads to that constant fatigue, that feeling of weakness, sometimes pale skin, and even trouble concentrating. Your body is literally running on empty.
All right, but what about the flip side? You might think, hey, more oxygen delivery? That's got to be good, right? Well, not so fast. Having too much hemoglobin can cause a whole different set of really serious problems. When your hemoglobin levels are too high, it actually makes your blood thicker and more viscous, almost like sludge. And you can imagine, this forces your heart to work overtime, to pump much, much harder to move that thick blood around. This dramatically increases the risk of developing dangerous blood clots, which, as we know, can lead to a heart attack or a stroke.
But wait, there's more. Beyond just telling us about oxygen, hemoglobin carries another incredibly important piece of information for doctors. It acts like a long-term health diary, and it's especially critical when it comes to diagnosing and managing diabetes.
And this is where we get the famous HbA1c test. Here's how it works. When there's too much sugar, or glucose, floating around in your blood, some of it permanently sticks to your hemoglobin molecules. It's like it gets sugar-coated. And since your red blood cells live for about 3 months, by measuring the percentage of this glycated or sugar-coated hemoglobin, your doctor gets this amazing snapshot, a clear picture of what your average blood sugar has been like for the past 3 months. It's a seriously powerful diagnostic tool.
Okay, so let's pull all this together, shall we? We've looked at hemoglobin's elegant 4-part design, we've seen its brilliant superpower of cooperative binding, and we've talked about its role as this vital window into our health. It's so much more than just another component in our blood.
I mean, from its incredibly clever cooperative binding that makes sure oxygen gets exactly where it needs to go, to its job as a key diagnostic marker for big things like anemia and diabetes, hemoglobin is, without a doubt, a true masterpiece of biology.
So, really, understanding your hemoglobin level is fundamental. It tells the story of how well your body is breathing, not just in your lungs, but right down at the cellular level. Which leaves us with one final thought to chew on. Is your body's critical oxygen delivery service running at peak performance?